Awesome. Let's take a look at our second page and let's track while we read the directions for this page. You're going to be doing some of this alone with your group, and we're going to do some together. Let's go. 1, 2, 3. Examine the graphs below and do the following for each problem. So they already numbered the directions for us. That's smart. 1, fill in the table. Okay, we're going to fill in the table for each one. 2, write the equation that relates x to y. Remember, that equation is always going to be y equals the constant of proportionality, or your unit rate, times x. 3, determine if the situation represents a proportional relationship. There's a couple ways we can do that. And remember, we can do that based on the graph, the table, or the equation. And 4, state the constant of proportionality. Excellent. Well, let's look at the first one together. So from my graph, I can fill in the table. That's the first thing they want us to do. So we have this point here is at the origin. Oh, that's 0, 0. The next point, the x is 1. I'm going to go up to the y value, and the y value is 2. The next point, the x value is 2, and over to the y is 4. Remember, y to the sky. And the next point is 3, 6. And oh, they gave us another point, so let's just extendo our table. Go, go, table. And if I have 4 for my x, well, my y is 8. Was that kind of predictable? Do you see any patterns here? Well, how do I go from 1 to 2? What do you multiply by? You're only allowed to multiply. Yes, multiply by 2. How do you go from 2 to 4? Multiply by 2. How do you go from 3 to 6? Multiply by 2. How do you go from 4 to 8? That's right, you multiply by 2. So if we want to know our equation, what are we doing to x to get y? To get y, we're going to multiply x by 2. Very good. Y equals 2x. Is this proportional? Why, yes, it is. It didn't ask us to explain why, but of course the graph is a line that, we shouldn't say line, a graph is linear and includes the origin. Our table has a constant unit rate. Our equation only has multiplication. Our constant proportionality is 2, and what point on the graph represents this unit rate? You can look right here on the graph, or you can use the table to find that in the graph. And I would like you to circle that unit rate so you can find it more easily. And that point is 1, 2. Make sure your point, your ordered pair, has parentheses around it, and it goes x, y. If it's not listed as an ordered pair, it's just a list, and it's not a coordinate or a location on your graph. So with that information, I'd like you to finish B, C, and D with your groups. Probably only need about 2 minutes for problems. That's 2, 4, 6. So please pause the video for 7 minutes, since you're also going to be talking. Pause the video for 7 minutes and let's finish up this page. Thank you for working together. Let's see how we did. After A, maybe you move to B, maybe you move down the page, but let's look at B for now. Your table should have been filled in 0, 0, 1, 1.5, 2, 3, 3, 4.5, 4, 6. Our unit rate is circled in our table and labeled possibly on our graph. And we also have our equation. We could write our equation with a decimal, y equals 1.5x, or y equals 3/2 x if you wrote this with a fraction. The point on the graph that represents the unit rate is 1, 1.5, an ordered pair, and our constant proportionality, again, you can write that as a decimal or as a fraction. Nice job on B. Let's move on to C. Moving on to C, when we are looking at our beautiful linear graph, we noticed, of course, we have the origin 0, 0, 1, 1, 2, 2, 3, 3, and 4, 4. We're always multiplying by 1 by the x to get the y. So our equation we can write as y equals 1x, or just y equals x. Is this proportional? Why, yes, the graph is linear and includes the origin. Our table has a constant unit rate, or constant proportionality. Our equation only has multiplication. Our constant proportionality is 1. And our point on the graph that represents that unit rate is 1, 1. Again, please make sure that's written as an ordered pair with parentheses. And the last one you were in charge of doing and did a great job on, I'm sure, is D. And again, wow, it's linear. The relationship's linear, includes the origin, which means it's proportional. Our table 0, 0, 1, 3, and 2, 6. We are always multiplying by 3 from x to get y, which means our equation is y equals 3x. We have a proportional relationship, and our constant proportionality is 3. The point on the graph that represents this unit rate is 1, 3. Excellent work. Let's keep on going. Thank you for turning the page with me and looking at page 34. We're going to look at a story and compare two different situations. So we're going to use the story to complete the following. Please have your trackers out and let's track. Milo and Sierra each bought chocolate cinnamon bears from different candy stores. Milo paid $3 for 2 pounds and Sierra paid $5.25 for 3 pounds. Let's assume the rates are proportional, which means they have a constant unit rate. They're not getting any deals if they buy more than 5 pounds or something like that. So let's complete the table for Milo and Sierra. Well, remember, Milo paid $3 for 2 pounds. So we know that the rates are proportional. If he bought 0 pounds, he'd pay $0. Cost depends on how much we buy. So I'm going to want to know about 1 pound, 2 pounds, 3 pounds, and 4 pounds. Well, are there any of these pounds we already know? That's right. We know that 2 pounds cost $3. Remember, we don't need to put the dollar sign here because we know that this is cost, and cost is in dollars. So then when we graph it, it's easier to graph 2, 3. So now, if 2 pounds costs $3, 1 pound, which would be half, would cost half as much as 3, which would be $1.50, or 1.5. So if you bought 3 pounds, that's going to be $1.50 more than 2 pounds cost. Good, 4.5. And then another $1.50 for the next pound. That's going to be $6 for 4 pounds. Let's complete also the table for Sierra's purchases. Sierra paid $5.25 for 3 pounds. I wonder if she got a better deal because she bought more. Well, let's find out. Of course, at 0 pounds, she spent $0. And I'm going to want to know about 1, 2, 3, and 4 pounds for Sierra also, so we can compare these. Well, $5.25 for 3 pounds. Well, here's 3 pounds, so that's going to be $5.25. Well, if I take $5.25 and I split it into 3, I can grab my calculator and do that. That's going to be my unit rate, or cost for 1 pound. So let's see, $5.25 divided by 3 gets me how much? Remember, this is pounds and that's dollars. Anyone have it yet? Oh, it's $1.75. Oops, don't need the dollar sign. $1.75 for 1 pound. And you can always use your calculator if you're not good. If $1.75 is kind of an awkward number, you can take $1.75, multiply it by 2, or add $1.75 to get the next cost, which would be $3.50 for 2 pounds. And then to go from 2 pounds to 4 pounds, well, you're doubling your pounds, so you're going to double your cost, and it's going to be $7. Perfect. Let's move down to B. What is the unit rate for Milo? So let's go back to Milo's table. What is the unit rate? Well, remember, unit rate is per 1. So when we look at our unit rates for Milo, his is, and we have to have units in a unit rate, $1.50 per 1 pound. What's your constant of proportionality here? Well, remember, the constant of proportionality is the same as the unit rate. So you can write that as 1.5. You could write it as 1.5. Or you can write it as 3/2. Those are all appropriate for Milo's unit rate. What point on the graph represents the unit rate? Well, we haven't graphed it yet, but we do have the table of values that represent the graph, which means the unit rate is 1, 1.5. Don't forget your parentheses. And now I need an equation that relates X pounds to Y cost. So the cost Y is always going to equal to something times the number of pounds. I'm always multiplying the number of pounds by the cost per pound. And how much did 1 pound cost? Oh, $1.50. So Y is going to equal 1.5 times X. And if you'd rather write that with a fraction 3/2 X, that's completely fine as well. You don't need both, you just need one. So let's concentrate now on Sierra and see if her relationship has a more expensive unit rate or not. So taking a look at Sierra's, what's her unit rate? How much is she getting charged per pound? Well, there's her unit rate right there. So she's getting charged $1.75. Don't forget your units and your unit rate per 1 pound of these delicious chocolate Cinnabars. So what's your constant of proportionality? Your constant of proportionality is the same value as your unit rate. So that means our constant of proportionality is 1.75, or if you like to write it as a mixed number, 1 3/4, or if you like to write it as an improper fraction, what's that going to be? 1 times square, what is it? What's the improper fraction? You're right, 7/4. What's the point on the graph that represents the unit rate? Well, it's when X is 1, independent value is 1. So that point is 1, 1.75. Don't forget your parentheses. So our equation then that relates X pounds to Y cost, to get the cost Y, what am I always multiplying X by? The number of pounds. Well, I'm multiplying X, the number of pounds, by the price per pound, $1.75. And if you'd rather write that with an improper fraction, 7/4 X, that's completely appropriate. Last two things we have to do is graph and then talk about who got the better deal. So when we're graphing these stories on the grid, it's really nice to either have two different colors or make sure we're labeling, because we want to be able to tell what's the difference. So I'm going to use purple for Milo. Maybe you have a pencil and a pen or something like that. I'm going to start graphing his. So 0, 0, 1, 150. So that's between 1 and 2, halfway there. 2 and 3. 3 and 450. So there's 4. So halfway would be 450. And 4, 6. Whoop, all the way at the top. And remember that this is Milo. So I'm just going to grab my ruler and I'm going to have to be very careful, make sure I'm lining up where, not just where the dots are, but where the intersection of the grid lines are. Maybe I need to label this M or Milo. Milo buying his chocolate Cinnabars. And then I'm going to use Sierra. Sierra also had 0, 0. So I like to kind of go around the point so I can show that it's on both of the lines. 1 and then $1.75. Well, if this is $1.50, should $1.75 be below or above it? Just a little bit above it. 2 pounds cost $3.50. 3 pounds cost $5.25. And 4 pounds, wow, we're off the graph, but be about there. So let's see if we can line up Sierra's graph. Label that one. And notice we don't have our axes labeled. Well, that's unfortunate. We definitely need those labeled. So our x-axis, remember, represents the pounds. And our y to the sky axis represents our total cost. And I like to put a dollar sign there just so we remember. So who got the better deal on chocolate cinnamon bears? Who got the better deal? And let's explain. Well, obviously, who got the better deal? Milo. Milo got the better deal. How come? He paid less per pound.